Hello and welcome to this webinar with regards to WIN-Statik punching. My name is Fredrik Lagerström and I am the product owner of Prestress, and I am also dabbling a little bit in the technical support of WIN-Statik and FemDesign. Today we are using GoToWebinar. So if you have any questions, they will be answered after the presentation. And in the interface, you have the possibility to ask a question. There are also one feature called raise a hand, but I will not be looking at that during the presentation. So if you have a question, it's better to ask them in the chat and I will answer them afterwards. This presentation will also be recorded and I will upload it and make it available on the Strusoft YouTube channel later today or early tomorrow. So, punching. We will look into the initial settings when you start up the program. We will take a look at a few modes in the program. Then we will look at material, input of geometry and reinforcements, input of loads, and bended shear reinforcement. We will also look at the calculation and presentation of results, and I also have a small verification. And after this PowerPoint presentation, I will also have a live presentation. And after the live presentations, there will be this Q&A session afterwards. To the right, we can see the WIN-Statik start menu launcher, and there you have the possibility to start punching. It's also possible that it is an icon on your desktop or in the start menu of Windows if you have it installed. This is one of the programs that we have a help video of, even though that the help video where you can switch from the program to help video, it is possible to look at that as well. It is in Swedish and it's made by my colleague Stefan Åberg, but for the English help, I would say that this presentation will serve just as good. So if we take a look at the initial settings, when you start up the program, you have the possibility to select a code and a national annex. As for the code in the latest version, it's always Eurocode that we look at, and we have 5 different national annexes and 1 standard Eurocode. If you want to use older national codes, I would recommend to use version 6.3, and we're at 6.5 at the moment. And in version 6.3, it is possible to design according to the old Swedish code, to the old Norwegian code, and to British standard, etc. When we select the code and national annex, we have the possibility to use the input drop-down menu, and here we can select the mode. And as for the Eurocode, it is possible to use a column, while in the older version, it was also possible to use punching of plate where you had a column on top of a plate and could see punching downwards, but that is not supported in the Eurocode version. And we have the possibility to select the section type of the column, if it's a rectangular or if it's a circular column. The next option is the material. And here we can select the exposure class, the concrete material, and the reinforcement. And depending on the national annex, you can also select other options. So what we see here is the Swedish national annex, where you can choose the water cement ratio for the life class. In the next selection, we use this window in order to define the punching area, the critical section, and what column type. And here it is the measurements of the column, the control parameter, or the critical section. And if this is set to 100%, then we have punching all around the column. But if it would be a hole within the punching region, we need to reduce this due to the hole, and then the control parameter can be reduced to, say, 90%, depending on the size of the hole. We also define the slab thickness, and this is the height of the concrete above the column. And if there is a steel plate on top of the column that is cast into the slab, then we have to use the height of the concrete above this steel slab. So it's basically where we have the punching of the slab. We also select the column type, if it's an inner column, a corner, or an edge column. When we have defined the geometry, we are presented with this view where we can see the slab, we can see the size of the column, and we also see the critical section or parameter going around here. We also see two red lines, and those are indicating the reinforcement. When we move on to reinforcement details, we define the concrete cover, and that is the concrete cover on top of the reinforcement bars on top of the slab. We also define the reinforcement bar diameter, and it's the same in both X and Y direction. And we also define either the reinforcement as a percentage or as a distance or spacing of the reinforcement bars. So here is the center distance of 100 defined in this. When we take a look at the loads, we define the forces from an ultimate limit state. So this should be basically 610A and 610B. And it is possible to have up to 10 different load combinations, all ultimate limit states. And when we also take a look at the different geometries or the column types, we have an inner column, and in that case, an eccentricity factor B is calculated from the moments that we supply here. And these forces can be taken from either a load takedown or a FEM design calculation file if you want to make a verification. But if we use an edge or a corner column, we will use the simplified parameters defined in Eurocode. So for edge, it's 1.4, and for a corner column, it's 1.5 for this beta factor. And if we have a hinged column in the model, then they may have no moments in FEM design, for instance, but we need to define a moment due to eccentricity. And this needs to be considered in the input, so we need to define those here. If the calculation is not okay, we have the possibility to place bended shear reinforcement or to use links. And as for the bent down bars or bended shear reinforcement, we can see one such bar here going through the punching cone. And the bending angle here is the angle of this inclined part of the reinforcement bar. As for the links, it's usually just normal standing stirrups, or if you use like a bended reinforcement that is placed standing on the bottom, and it just goes up and through the punching cone. The most effective would be the bent down bars, basically because it's quickest to place on the construction site. When we take a look at the calculation, there is a quick result popping up here where we can see if we have the capacity needed. So there are or there might be different load cases. In this case, we only have defined one, and then we can see that the punching is okay if in the comments it says okay. There's also one result for the control parameters. So you can see what the column parameter U0 is and the control parameter of the punching cone and what the parameter of that is. And also we can see the eccentricity factor beta here. And for an inner column, it will be calculated, but for edge and corner, we will use the Eurocode values. If the calculation is okay, then the red bars will turn blue, basically just give an indication of that this is okay. If the bars are still red after the calculation, more bent down bars or the links might be needed. So an extra shear reinforcement might be needed there. And this is shown here with regards to saying that it's not allowed. And in this case, I have increased the load to basically force it to not be okay. And in this case, two more options will show up, and that is the shear reinforcement bent or link reinforcement that you can calculate. And if I use the bent down bars, an extra presentation will be shown here where it's possible to see the capacity. and also the number of cuts crossing the critical punching cone. So here we need 10 cuts of reinforcement, so 5 bars. And here we can see the extra reinforcement required needed in the parameter. When we are going to print the results, we can select the detailing level, basically showing the tables in the input and results, but also some graphics in the geometry. And the presentation is normally on 3 pages, depending on how many load cases or load combinations that you have defined. And all the information needed here will be shown here as well, where the normal reinforcement is not allowed. It will say so. And in this case, if it's not allowed, we also print the extra bent down bars that is needed. The one important thing that we often get in the support is that people are doing verifications between the WIN-Statik punching and the FEM design, and it's very common that the customers say that there is something wrong in between here. But the most important part is to actually verify the in data that you have in order to actually verify the same problem. So it's not 2 different issues. And if it's modeled correct, we can see the design stress and the capacity at the column parameter U0, and that is shown here in FEM design. And then we also verify the control parameter U1, or at the punching cone here, and that is shown out here in FEM design. Now I will have a live demonstration, and I will use the WIN-Statik launcher, and if you have the any of the WIN-Statik software installed, there will be a WIN-Statik launcher icon shown on the desktop. Here it is possible to see the help videos for some of the programs. But I will start punching, and here I will select the code, and since this is the latest version, it is 6.5, and here we have the different national annexes, and in the most recent update we also added the Swedish annex, the latest one there as well. But for this example I will just use normal standard Eurocode. When starting, we have the input, and I will also show a little bit about the title. Here it is possible to write down the title of the project, who is doing the calculation and so on, and this presentation or information will be shown on the printout as well. In the mode, I will select a column, and I will select a rectangular. Material, here I have the possibility to select either a concrete defined in Eurocode, or I have an user option here to define my own concrete. Today I will use C3037, and it's possible here to define the exposure class and life class. And these values will also affect the concrete cover needed. Similar with the reinforcement, there is usually one defined for each national annex, but it's possible to have a user-defined reinforcement here as well. In the geometry, I will define the size of the punching or the column. So I will check a column that is 200 by 250 millimeter. It's an inner column that has no holes around it in the slab, so the control parameter is 100%. And this is basically just scaling down the capacity. So if I would have a hole that is 10% of the control parameter or affecting 10%, then I will only have 90% of the capacity left. The thickness of the slab, or rather on the concrete above my column or punching region, I will say is 250, and it's an inner column. If I would select any other column, corner or edge, I will be able to define the distance from the edge to the punching region. As for the reinforcement details, I will use code dependent, and this means that the program will actually check according to the national annex what the concrete cover is and that it is okay. So here I will enter 25 millimeter as concrete cover, and if I would just check an existing column, then it might not be according to the code, and it's, if you don't want to have this check that you might know that it's designed according to an older code, it is possible to uncheck the code dependent, and then there will be no check. So if I would just have written 12 millimeters, it will not warn you that this is not according to the code. Here it is also possible to define the reinforcement bars. They are set to diameter 10 here, but I will select diameter 12. And I will define a spacing of 150 millimeters in each direction, and we can see that it's updated here, diameter 12, spacing 150 in both directions. When we take a look at the loads, I will define two load combinations here. And as I mentioned before, up to 10 different combinations can be performed in each model. Just taking a look at the reinforcement bars, and if some bent down bars are needed, I can define them here with regards to the picture that I saw shown before in the PowerPoint presentation. I will calculate the capacity and they turn blue, so that's a good sign. And I can show the capacity and the general information here. And in the capacity, we see that we have a design stress and that we have a capacity. And this is at the column parameter, so this is just around the column. And we also have a control parameter, and that is the red dashed line out here, where we have a design stress and a capacity as well, and they are both okay. And in the general part, we can see that it's different eccentricity factors depending on the load combinations that I entered, and that is due to the moments are defined different, or that they are different. So I get different eccentricity factors. If I instead would increase one of the loads to 440, and I will change the reinforcement to diameter 100 instead. We can now see after the calculation that the reinforcement bars are still red. So I need to it's possible to see that it's not allowed here, that I have a higher design stress. So I need to do something around here. So I will calculate the bent down reinforcement. These initial calculations are still the same, but I now also have one option to see the bent down bars, where I have my bending angles, my diameters, and that I need 10 cuts or 5 extra bars that's passing through here. So each cut here is when it's passing through the critical parameter. And we can also see that one of the values here is negative, which means that I don't need it. It's actually a higher capacity than I actually need. So I can basically say that I can remove 2 bars from this calculation because it is too much. And when I have this, I can go out to printout options. The default is that it is all checked. And I go into the print. I select the standard layout. And I have my presentation with all the in data, all the different calculations needed. And I also have the third page, which is a table of contents. And that concludes the live presentation. If you have WIN-Statik, you may, or the punching program, you may try it out, of course, but if you don't have it, you are welcome to get a free trial, and then you just go into the Strusoft homepage, browse to WIN-Statik and press the get a free trial, and you will have the possibility to get a trial license or a quotation if you want to buy it as well. There is one option to book a demo, but this demonstration that I've done now would serve basically the same as what we've shown here. And the next webinar will be held on the in the WIN-Statik for in English will be held on the 30th of November, and that will be regards to the program Concrete Corbel. And I wish you a good day, and I will hope that I see you next time.